Hello and welcome back for another day of Spark and AI Summit. We have another great lineup for you today, but before we dive in, I want to start by announcing our Data Teams Unite Hackathon winners. We launched this hackathon back in May to see what kind of solutions data teams could come up with to help address issues around COVID-19 crisis, climate change, and social issues in their communities. We received over 50 submissions, but 3 in particular bubbled up to the top as the winners of this hackathon. I'll start with our third place winner. In third place, congratulations to the data team from Booz Allen Hamilton, who focused on climate resiliency for the Chesapeake Bay. As a prize, Databricks will donate $5,000 to the Alliance of Chesapeake Bay on their behalf. The team combined data from nitrogen in the water, climate data, and land use data to build a model that could predict nitrogen concentrations in the bay based on historical conditions. Congratulations again to the data team from Booz Allen Hamilton. Now, for our second place winners. A big congratulations to the data team from Shell and Enbridge, who built a wildfire real-time detection system using satellite imagery. As a prize, Databricks will donate $10,000 to the Amazon Conservation Association on their behalf. This team trained the UNet based on a conv neural network using MLflow. Given a satellite image, it predicts the mask of the burned area of an image of a forest and estimates the total CO2 emissions. So great job and congratulations again to the data team from Shell and Enbridge. And last but not least, our grand prize winner for the Data Teams Unite Hackathon is the data team from RevGen in Denver, Colorado, who led a project called Taking It to the Streets. As a grand prize winners, Databricks will donate $20,000 on their behalf to an organization called The Gathering Place, which is a Denver-based drop-in center serving impoverished or homeless women, transgender individuals, and their children. For their project, this team focused on the COVID crisis. They wanted to help businesses expand into the roads, increasing capacity while also keeping customers safe. So they used data science to determine on a street-by-street level the economic costs and benefits of street closures. They found that restaurants benefited the most of all types of businesses when streets were closed. They used Python, SQL, R on Delta Lake to take advantage of the team's diverse skill set, and they've already begun conversations with the City of Denver officials about the analysis. Congratulations again to the RevGen team. In addition to supporting these important causes on behalf of the winners, I want to remind you about our fundraising goal here at Spark and AI Summit. The Center for Policing Equity and the NAACP Legal Defense and Education Fund are 2 organizations that are doing incredible work to help drive racial and social justice. We set an ambitious goal of raising $100,000 yesterday, and we've made a great progress on this so far, but we've got more work to do. Databricks will match all donations up to $100,000, so together we have the ability to raise $200,000 for these important causes. Please do take a moment and click Donate Now in your dashboard and help us reach your goal. I hope you were able to catch the keynote from Dr. Goff from CPE, along with the other keynote presenters yesterday. We have another great lineup of speakers for you today, both in this morning session and in the afternoon. And to get us started, I'd like to quickly pick up where we left off yesterday. Yesterday, we talked about the lakehouse pattern and what we see emerging and how open source projects like Spark 3.0, Delta Lake, and Redash, as well as innovations like Delta Engine, make this a viable architecture to support a broad range of data use cases. Today, we're going to zoom in to 2 of those use cases. First, we'll talk about how we can enable data teams to work better together with collaborative data science. And second, Matej will lead the talk, enabling a full life cycle of machine learning with MLflow, which has quickly become one of the fastest growing open source projects in our space. So without further ado, I'll summon Clemens Mewald to talk about the new data science workspace.
Whoa, thanks, Ali. It's great to drop in. And let's jump right into the next generation data science workspace. And I'd like to start with some old news. If you're attending this conference, you probably don't need any more convincing. The data and AI trend has been transforming all industries for a couple of years now. Almost all major companies are realizing that these investments lead to competitive advantages. Now, if you ask me, I don't know what those remaining 12 Fortune 1000 companies are up to. And as a result, the job market has been playing catch up to meet the demand. 3 out of the top 8 jobs in LinkedIn's latest emerging jobs report are data and AI roles. Congratulations to you if you're in any one of these categories. I'd say you have some pretty good job security ahead of you. Now, one thing you will notice is that there's a diversity of roles needed to deliver on these strategic initiatives. is not just one abstract data and AI engineer. Solving the world's toughest problems really is a team sport. And you need all of these functions working together as a team and not in isolation. Of course, at Databricks, we call this unified data analytics, and we've built a platform for that. Collaborative data science workspace becomes the focal point of such a platform. It needs to cater to all of these users' needs and bring them together. Today, I'm going to introduce you to the next generation of our data science workspace, an open and unified experience for modern data teams. But before we do that, let's look at where we're coming from. And we've already come a long way in simplifying data and AI to help data teams innovate faster. On the left here, you can see a MapReduce program to count words. You should probably remember this just in case it ever comes up in an interview. Of course, writing this code snippet is just the first step. Back when this was still cutting edge, you would still have to worry about setting up a cluster, writing a couple of more lines of configuration, and hope you get it all right. Thankfully, today, you don't have to worry about any of this. In Databricks, you just write a Spark SQL query and hit run. The cluster in the background autoscales for you, and you just sit back and wait for the result. Now, of course, this is a very simple example, but it extrapolates to the full complexity of data engineering at scale. But as mentioned, this is only part of the solution. Where are we when it comes to data science today? When it comes to productionizing data science projects today, we're still dealing with a big mess. If you've ever tried to do statistical data analysis, or maybe train a machine learning model, you know that the tools that are supposed to make your life easier are still very difficult to use. In fact, according to one study, only about 15% of those Fortune 1000 companies have deployed AI capabilities into widespread production. The reason, of course, is that the tools available to these companies, specifically in enterprise software, haven't kept up with new emerging practices in data science and machine learning. And as a result, we are made to choose between 3 bad options that are all not that great. The first, and for many the most natural option, is to just give everyone the freedom to do whatever they want on their laptop. Of course, data scientists love that. You have full freedom to install anything you need, and you can move fast. However, you're pretty far away from your data. You'll need to downsample and copy data onto your laptop. And of course, you don't have to sit in compliance to know that moving sensitive data onto your laptop is generally a bad idea. And the folks who are maintaining your production systems are definitely not going to be happy to try to reproduce your local environment. To address some of these concerns, some vendors take the approach to just put those same tools you use on your laptop into the cloud. Essentially, they're giving you a virtual laptop. Now, however, just hosting Jupyter and giving you a VM with scikit-learn or TensorFlow pre-installed isn't that much of an improvement. Sure, you no longer have to copy data onto your laptop, but aside from security and governance, there are no obvious benefits, just more constraints. And finally, you may be asking yourself the question, why not iterate on our production infrastructure directly? Well, unfortunately, those production-hardened systems are not really ideal for exploration. And most data scientists will not be happy if you try to teach them Kubernetes. So you're left with a hard choice: full freedom of a laptop, slightly worse experience with the same tools in the cloud, or a fully production-hardened system that no data scientist will want to use. Thankfully, we're in the 21st century, and with a little customer obsession and engineering, we've been able to navigate these trade-offs. Our solution for modern data teams starts with the premise that developer environments need to be open and collaborative. Our workspace follows open source standards and provides a collaborative notebook environment on a secure and scalable platform. Next, the industry has already figured out best practices for versioning and CI/CD, and they're Git-based. So we integrate our platform with this ecosystem and provide those best practices to data engineering and data science, where reproducibility is becoming more and more important. Finally, to reduce the time from experimentation to production, the same environment can be scaled to production deployments, allowing you to manage the full lifecycle within one platform. And bringing all of this together, I'm extremely excited to announce the next generation data science workspace on Databricks. And without further ado, let me walk you through some of these innovations step by step before we give you a demo. This is a screenshot of the current workspace navigation in Databricks. It brings together all of the components you need for collaborative data science: notebooks, clusters, jobs, models, and access to all of your data at any scale. For those of you who are familiar with this interface, you may notice something different. We're introducing a new concept called projects to the left navigation panel. One of the most common ways that data scientists start their work is to clone a Git-based repository. With projects, you can bring all of your work to Databricks, where you can access all of your data and use best-of-breed open source tools in a secure and scalable environment. Because projects are Git-based, you can keep them in sync by pushing and pulling changes. Of course, you can also switch between branches or create new ones. This basic functionality provides you with a powerful set of capabilities to integrate your Databricks workflows with your CI/CD automation. It then enables you to follow best practices when you move from experimentation to production. And you don't have to learn DevOps tools. Now, many of our customers have been waiting for this projects feature, and I'm happy to announce that it is available in preview today. Now, we have many more exciting features coming, and I'll give you a quick sneak peek of those as well. At the intersection of Git-based projects and environment management is the ability to store your environment configuration alongside your code. This integration will allow us to automatically detect and enable your environment, removing the need for you to worry about installing library dependencies yourself. And you know, sometimes saying it just works is the most powerful statement. And in this case, we make it just work. Following the same behavior you're used to on your laptop, we give you an environment that matches your environment specification and make it available consistently on all workers on an autoscaling cluster. So now that your environment is all set up, let's look at your code. You can already import IPython notebooks to Databricks. This allows you to convert your Jupyter notebooks to Databricks notebooks and vice versa. In the future, we will store these notebooks in their native format, removing the need for conversion. This not only makes Databricks more standards compliant, but it also enables us to support alternative editors. So if you want to, we allow you to open these notebooks in Jupyter right here in Databricks. And similarly, by the way, for the R users among you, we also support RStudio. However, as mentioned earlier, just providing you with cloud-hosted open source tools is not quite good enough. So by default, we will open these notebooks with the Databricks Notebook Editor. The Databricks Notebook Editor can open Jupyter notebooks and in addition provide you with collaborative features like co-presence, as indicated in the top right of the screen, and real-time co-editing, as indicated by a colored cursor. And to facilitate collaboration even more, Databricks notebooks also allow you to comment and leave comments for your colleagues, all in one cloud-based environment. Now, by allowing you to open Jupyter notebooks in the Databricks Notebook Editor, you will no longer have to make the trade-off between using standard formats and the collaborative features and benefits that Databricks provides. So in summary, this is our solution for modern data teams. I showed you how we provide collaborative notebooks based on open standards, integrate with the Git ecosystem for collaboration and reproducibility, and provide integrations with CI/CD systems for a robust workflow from experimentation to production, all on a secure and scalable cloud platform. But you don't just have to take my word for it. So let me introduce Laura and Richie, who's going to give you a demo.
Thanks, Clemens, for the introduction. Let's jump right into the demo. For the purposes of this demo, imagine I work at a big retail company. We used to do our forecasts on a quarterly basis. It's a big effort for our data scientists to come up with those forecasts using many different tools. And once that is done, we print them to PDFs and send them out by email. That has led to lags in decision-making because we use outdated forecasts. Of course, these days, the world is changing at a rapid pace, and our leadership team has asked us to move from a quarterly to a weekly basis. That will significantly improve the quality of our business decisions, like how much inventory to order. The amount of manual work involved in producing this forecast is prohibitive in doing this more frequently. So, as a good data scientist, I am determined to automate this process and provide our decision makers with an interactive dashboard that always has the latest forecasts ready. First, I'm wondering if there's a better tool for those forecasts. So I searched Google for Python forecast libraries because I know that there's a lot of innovation. And I find this library called Profit, which was open sourced by Facebook. I read about it online and heard good things, so I'll check it out. Of course, there's a lot of toy examples available online. So I found one and forked it into my GitHub account here. As you can see, it comes with a dataset and a Jupyter notebook that shows you how to create a forecast. This is great. Usually, the way I go about this is to take an example like this and try to recreate it just to make sure it's not outdated. So I click clone to get the repo URL because I'll need it in a minute. So here I am in my Databricks environment, which we call the Workspace. In the past, it would have been pretty difficult to get code from a Git repository into Databricks. However, as Clemens mentioned, we now have this new feature called Projects, which allows you to easily clone a Git repository. When you click Create Project, you provide the path to a Git repository. So I just paste the URL that I just copied earlier into this text box. When you click Create, we clone this repository and make it available in your user folder. As you can see, it indicates which branch you're on. And when you click into the project, you see that all of the files were cloned. So the first thing that I'll do is to create a branch, because I don't want to mess around with the master branch, because that will be used to run our production job. I open the Git dialog, and I can just start typing a branch name into this text field. Now I click on Create Branch from Master, and I'm ready to go. As you can tell, we're trying to make the most common workflows super easy without having to leave this environment. Now that I'm in my feature branch, I'll click on the Jupyter Notebook, and you'll see that we open it in the Databricks Notebook editor. In addition to supporting standard formats, this editor gives you several collaborative features that we'll highlight as part of this demo. So let's get started. Databricks provides you with a scalable compute backend. I can attach a notebook to an existing cluster or create a new cluster. Let me attach this notebook to this cluster called MLcluster that's already running. Now, usually, I would have to worry about the environment that is set up on this cluster and the libraries that are installed. But with the integration of the projects feature and our runtime that's running on this cluster, you will see that we automatically detect the presence of this requirements.txt. And as soon as I run any cell in this notebook, the cluster will make sure that the environment matches those requirements. So what's happening now is that Prophet is being installed in the background. We already pre-install many popular libraries like Pandas and NumPy, and we adjust their versions if needed. So let's just run this entire notebook and see if it works. As you can see, this reads in the CSV file from the data folder and loads it into a Pandas data frame. The file has two columns, one for date and one for the historic values of the column that we will try to forecast. In this plot, you'll see that we have data up until 2016, and then we forecast for another year after that. This is great because that's usually how you get started. Find an example and make sure that it works. However, this is just using toy data, and we have lots more data on our actual stores. So let's see if we can adjust this example to actually scale to our needs. I don't actually know where our sales data lives, so I leave a comment to ask my colleague to help me out here. Okay, let's see if he's online. Great, coincidentally, it looks like he's online and ready to help. You can see he opened up the notebook from the indicator up here, which shows which users are present in the notebook. Okay, looks like he responded. And he created a cell, so I'll assume he'll just share some code. Okay, great, he's actually using Koalas. Koalas is an open source library developed by Databricks that provides the exact same APIs, but uses Spark in the backend to scale computation. This way, I won't have to change any of the other code. The data frame is still named DF, and it should just work. So if I run this cell, you'll see that we're running a Spark job in the background and hand you back a data frame. This is now different from the toy example before. We have an additional column that indicates the store this data is from. In this case, we only have 3 for now: San Francisco, Amsterdam, and New York. Of course, I don't want to generate a forecast across all stores, but I want to have a forecast for each store individually. So instead of just running all of this through one big forecast, I group the data frame by store ID and apply the forecast as UDF. What will happen is that we'll run a Spark job, group the data frame, and then for each store, we'll run this forecast. And I can also delete all of the other cells because we won't need them. Now, the only thing missing is that I want to write the forecast out to a Delta table to actually use it in my dashboard. I don't just want to run the forecast every time someone wants to look at it. So I add this code snippet that takes the forecast and stores today's date and the store ID so that I can query by that later. When I hit run, we'll bring up some Spark jobs in the background that crunch through those data and write out my predictions. Now this is great. I just cloned an example I found online, Databricks configured the environment for me, and I could easily change it all to scale all of my data by using koalas and writing out forecasts to Delta. Now, as mentioned earlier, if for whatever reason you want to use Jupyter, you can right-click on this notebook to open it with Jupyter right here in Databricks. Unfortunately, the collaborative features you just saw are not available in Jupyter. As a side note, of course, you could go back and forth between the two editors whenever you want. Okay, let's go back to the Databricks notebook editor. Of course, I've been working off of my feature branch here, so now I can go and check that code into Git. I open the Git dialog, provide a commit summary, and click Commit and Push. We won't show this in the demo, but usually you would go through the typical CI/CD workflow to create a PR, get it reviewed, and merge it into master. And here we set up our Git automation to automatically check out the master branch of this repo in this production folder whenever a new PR gets merged. From here, I can just open up the notebook. Now this is the master branch version that I want to automatically run. You can click on this calendar icon, which allows you to schedule this notebook as a Databricks job. Let's configure it to once a week, and this way I'll automatically get the new forecasts written into my Delta table. I'll click OK, and we're done here. Now this is a full end-to-end lifecycle of experimenting with code in my own feature branch, checking it into Git, and pulling the master version into a production folder that is used to run a scheduled job. Let's quickly take a look at the dashboard that I put together. In this notebook, you can see that I use a feature of Databricks notebooks called Notebook Widgets. I can just create 2 widgets that give me the fields available in the Delta table. Those widgets will update whenever I get new data. And then the data that is shown is automatically filtered by my selection. I can create a dashboard from this notebook that embeds the table and visualization and also integrates the widgets to control the parameters of the SQL query. So when I click Present, you will see that the version of this dashboard that I'll share with our decision makers. Here they can select which forecast they want to see for which store, all updated and without having to write any code. And that's it for the demo. So just to summarize, in this demo, I showed you our support for the native Jupyter format and how the Databricks Notebook Editor provides collaborative features like co-presence, co-editing, and commenting. We saw the project-based Git integration and how easy it was to start by cloning a Git repository and creating a new branch for development. And finally, we productionized the forecast by pulling the master branch into a production project, scheduling a job, and creating a notebook dashboard to share the latest results with our business stakeholders. Now, in theory, I could even update these forecasts every day, simply by scheduling the production job to run daily. That's a massive improvement from the quarterly cadence that we were used to. And with this, I'll hand it back to Clemens.
Thank you, Lauren, for this amazing demo. I hope that everyone watching is as excited about the next generation data workspace as we are. To learn more, check out databricks.com. And with that, I'm going to bring back Ali.
Thank you, Clemens. I hope you're as excited as we are about the new and improved Databricks Workspace. As companies continue to mature in their machine learning practice, the need for robust and reliable platforms capable of handling the entire ML lifecycle, from experiment tracking to model deployment and management, is becoming crucial for successful outcomes. 2 years ago, at Spark and AI Summit, we unveiled MLflow, an open source machine learning platform for the whole lifecycle. And today, we have some very exciting updates to share with you about MLflow. So please join me in welcoming MLflow's original creator, Matej Zaharia, back to the virtual stage.
Hi, everyone. I'm excited to give you an update on MLflow, the open source machine learning platform. So I'll start by talking today about the need for machine learning platform and what these software systems are. Then I'll give you an update on the MLflow open source community, where we have some exciting announcements. And finally, I'll talk about what's coming next for MLflow. I think everyone at this conference is aware that machine learning is transforming all major industries, and it's involved in day-to-day and even second-to-second decisions in a lot of applications and business processes. But at the same time, despite the huge potential and value of machine learning, building machine learning applications is highly complex, and it's quite a bit more difficult than traditional software engineering. So this is for a few reasons. First of all, machine learning development is a continuous iterative process. The real world keeps changing, and so ML applications and models have to be continuously updated over time. Second, these applications are highly dependent on data, so you need to have very solid and reliable data pipelines, both during training and production. And finally, as a result of this, many different teams and systems have to be involved in these applications, including data engineering, machine learning or data science, and application development teams. And this complexity makes it very challenging to build and then operate machine learning applications. Now, as a result of this complexity, there's actually a whole new category of solutions that's emerging in the industry called machine learning platforms. These are software platforms to manage the machine learning application lifecycle, all the way from data to experimentation and finally to production. And these have already been very successful in the largest companies that use machine learning. So for example, Google's TFX platform, Facebook FB Learner, and Uber Michelangelo are all internal platforms that power hundreds of applications at these companies. But we found that every company using machine learning in a serious way is developing some kind of platform, regardless of their scale. And these platforms have some key benefits. The main one is that they standardize the ML development and management process within each company to make it much simpler. But the way that companies are building them today also has some significant challenges. In particular, today, each company is building and maintaining its own platform, and that's a lot of replicated work. And it's also quite difficult to do because machine learning technology is changing very quickly. So if you're developing one of these platforms, you constantly have to add support for new versions of ML libraries, new algorithms, new deployment processes, and so on. So at Databricks, when we started looking at this problem about 2 years ago of how to provide an ML platform, we asked ourselves whether we can take a very different approach. And unlike these existing company internal platforms, we wanted to create a platform that's open source and that a broad community can collaborate on so that it's very easy for everyone to have the latest and greatest support in their machine learning platform. And that's what we did in MLflow, the first open source end-to-end machine learning platform that we launched actually 2 years ago at the same conference, at the Spark AI Summit. So MLflow consists of 4 components that work together to manage the machine learning lifecycle. They include MLflow tracking for experiment management, MLflow projects for reproducible runs, MLflow models to package models and then deploy them in a reliable way to different deployment backends. And finally, the model registry, which is the newest component. It's a centralized hub to share and review models for an organization. And these components all work together. Any individual involved in machine learning can use them. And they're also designed around this open API philosophy where everything is using REST APIs and command line interfaces that are easy to integrate with existing tools. So in particular, this means you can use any programming language with MLflow through these APIs. And you can also use any machine learning library. And the community has actually built great integrations with a lot of very popular libraries. But it's also very easy to integrate MLflow with your own custom processes. So when we launched MLflow, we had no idea how this project would do. Would it be possible to design an open source platform that can actually provide value to all the companies that have to build their own custom process? And also, would there be any kind of community forming around it? And we were really blown away by how quickly the community has grown. Today, 2 years later, MLflow is already up to 2 million downloads per month just in Python alone. That's quite a bit more than many individual machine learning libraries. And it's also up to 200 contributors from 100 different organizations. Just for comparison, our team working at Databricks is less than 20 engineers. We're also seeing very high usage just on our own cloud platform. We see over 1 million experiment runs tracked per week with MLflow and 100,000 models registered that people want to share with their team and review. And these numbers, both usage and downloads, are growing at a rate of 4 times year over year. Very fast growth rate at this stage. Just to give you an example of the breadth of use cases, at this summit we have a number of talks on MLflow, including the 3 that I'm highlighting here. So T-Mobile has been using MLflow to maintain their ad fraud detection platform, where they need to monitor over 200 metrics from different data sources to make sure that the models are not drifting and are giving accurate results. ExxonMobil is using MLflow to deploy and then monitor thousands of models for predictive maintenance across their business. And finally, Virgin Hyperloop One is designing this high-speed Hyperloop transport system, and they're using MLflow for experiment management to look at the results of thousands of simulations about all aspects of the system, not just machine learning. And they've been able to increase, the projected efficiency of the system quite dramatically by running all these experiments. So these are just some example use cases that you'll see full talks about. Because the community has been growing so quickly, we also wanted to make sure that it can keep doing that in the future. And I'm really excited to announce at this summit that Databricks has donated MLflow into the Linux Foundation, so that now there's a large, nonprofit, vendor-neutral foundation that's managing the project, and that'll make it very easy for a wide range of organizations to continue collaborating on MLflow. And we're really excited to see how this can lead to even more organizations building on and contributing to MLflow in the next few years. Okay, so that's been a little bit of background on MLflow and an update on the community. The last thing that I want to talk today is what's next. At Databricks, we're doubling down our investment in MLflow, and quite a few other companies are contributing heavily to it as well. So in particular, I'm going to talk about 3 ongoing efforts: autologging, model governance, and model deployment. So let's start with autologging. In MLflow, it's easy to record custom information about your training runs. And one of the tools that we added to do that is these integrations called autologging into a lot of popular machine learning libraries. So you can just write one line of code, and MLflow will automatically record a lot of details about the models you trained using that library and the metrics about them. So all the parameters in your model, the actual model file itself, so you can then deploy it in different places, all the training curves, and so on. We started providing autologging features last year, and we've seen very fast adoption of them. So we're actually adding quite a few exciting new features. One of the ones that I want to talk about that came out in MLflow 1.8 recently is autologging for Spark data sources, which is our first foray into data versioning with MLflow. So if you're using Spark to create your features or your training pipeline, you can turn on Spark autologging and automatically record exactly which data was queried. And in addition to that, if you're using Delta Lake, which has support for table versioning and traveling back in time to see an old version of the data, we also record exactly which version number was used. So what this means is that if you're running your job with Spark autologging, you'll get this information about what was read, and you can then reload the exact same table version later. And this is incredibly useful for debugging your model later on if you want to see what data went into it, or for creating new models to compare with it, and so on. It's one of the biggest pain points that we've seen users have when they manage data and they're trying to do machine learning. So this is already out. We're excited to see what people do with it. There's also MLflow autologging support in quite a few other libraries. There are 6 libraries that are already supported in the main repository. And there's also a team at Facebook that's contributing PyTorch autologging. And at Databricks, we're working on scikit-learn. And we expect to see new autologging integrations with a lot of other systems as well. The final new feature I wanted to mention with autologging is that if you're a Databricks customer, we've integrated autologging with the cluster management and environment features in Databricks. So if you are doing experiment runs on Databricks, for example, in a notebook or in a job, we will automatically record both the version of the notebook that you used, an exact snapshot of it, and also the cluster configuration and any libraries that you attached. And then we provide this clone run button, so it's very easy to create a new cluster with exactly the same configuration and libraries as your notebook, and create a snapshot of the notebook as it looked back then, and run it again or modify it. So this really shows the power of autologging. It's going to be super easy now to get the exact same environment and reproduce and iterate on results. Okay, so that's the first feature I wanted to talk about, autologging. The next important set of features is, of course, once you've done a bunch of experiments, you've built machine learning models, and we see one of the biggest pain points of organizations is around model governance and reviewing and deployment. So we're actually adding a couple of very exciting features to the MLflow model registry to help further with this process. The first feature is MLflow model schemas. So we found one of the most common pain points with deploying models is that you might have, the data that the model was trained on might have different feature names or different, different properties than the data that you have in production or even the data you used in your previous model. And so we're extending the MLflow model format to include support for schemas, which store the input and output data types for your models. And whenever you call one of the log model APIs in MLflow, it will now also record these schemas. So it will record, what fields are required as input for your model and also what it produces. And then we'll use these in the rest of the MLflow tools to check for compatibility and warn you if you're deploying a model that needs to work on a different type of data from your previous one. You can just compare two of the models and get a warning that these are incompatible with each other. And we think this will be extremely useful, when you plug in through the API into different deployment tools and other custom review tools that you might have. So that's model schemas. The second feature I want to talk about is extending the model registry with custom tags. So we found that a lot of organizations have very custom internal processes for validating models. For example, maybe your model has to pass legal review for GDPR compliance, or maybe it has to pass a performance test so that you can check whether it's fast enough to deploy onto edge devices. So we're adding these tags as a mechanism to add your own custom metadata for these models and keep track of their state. And this also integrates with APIs, so you can run automatic CI/CD tools that test your models, add these tags, and check off on them, and make it very easy to check whether your model is ready for deployment. And we think this will help a lot of workflows around model management get quite a bit easier and more automated. Okay, and the final set of features I want to talk around are model deployment. MLflow already has integrations with a lot of model deployment systems. It's very easy to push your model to them, but because we're seeing so many of them contributed, we actually wanted to make deployments a first-class concept and give you a single API to manage all these types of deployments. And so we're creating this deployments API for managing and creating deployment endpoints that will give you the same commands to deploy to these different kind of environments. So you don't have to worry about the individual details. This is already being used to develop 2 new endpoints for Redis AI and Google Cloud Platform. And we're also porting a lot of the past integrations that we had for different deployment systems to go behind this API. So this will give you a simple, uniform way to manage these deployments and to push the same model to different serving platforms. And for Databricks customers, we're also really excited to announce a model serving system integrated directly into Databricks. So if you use open source MLflow today, you can already track models and use the model registry to manage the different versions of them and push them to different serving systems. But if you happen to be doing this on Databricks, there's also now a turnkey way to directly deploy models from the registry. As soon as you promote a new model to production, it will automatically be served in a REST endpoint. And so data scientists can do this without involving anyone else at all in upgrading the service. And of course, you can hold back by just querying a different version or moving the version out of production. So a very simple turnkey way to do this, but we think it will make it even easier if you are using our hosted MLflow service to productionize your models. Okay, so that's an overview of the new features. It's nice to hear about them, but it's even more exciting to see them in action. And for this purpose, I'd like to invite Suan Hong, a staff engineer on the MLflow team at Databricks, to give you a demo.
Thanks, Matej. There's a lot going on in the world these days, so I've been reading a ton of puppy news. But even puppy news can be overwhelming. For example, as a new mom, I don't know how I feel about 14 puppies. So I decided to build an AI-backed browser extension to tell me how to feel. Let's turn this on. All right. I think emojis make internet better, and I can get behind 14 puppies being good news. They're very cute. Let's see. It's not always correct, but it looks pretty good. So today I want to tell you how I built this real-time machine learning application in just a few minutes and how I can make it even better using MLflow experiment tracking, model registry, and Databricks model serving. First, I need a sentiment analysis algorithm that will take text and return an emoji. I'm using Vader here, which is a rule-based algorithm. I've constructed the model, and I want to log some information about it to MLflow tracking for posterity. I'm going to log the algorithm name as a parameter, as well as number of sentiments, and we'll also log the test accuracy as a metric. Accuracy is not bad, so we'll try putting this into production by logging the model to MLflow run and model registry by specifying this registered model name parameter. We'll also log the model schema or signature, which is a new feature that Matej mentioned earlier. And this model takes in a string and outputs another string, which should be the emoji. We've created version 1 of model text to sentiment in model registry. To see all that we've logged here, we can go to the run sidebar, which lists all of the runs that were logged from this notebook. Clicking on one takes us to the run details page, which has a link to the source notebook snapshot, parameters, metrics, and the model that we just logged. To go to the model registry, we can click on this link, or we can use the model sidebar and search by name. We have our version 1 here, and I really want to use it in my application right now, so I'm going to transition its stage to production. Now we can go to the New Serving tab and enable real-time model serving behind the REST API interface. So with one click, we're putting up an endpoint that will call these machine learning models on demand. Our version 1 is pending, but once it's ready, it will be available at this URL that is the Workspace domain, the model name, as well as the version number or the stage that it's in. So this production URL for this model is pointing to version 1 right now. Let me copy this URL. And while the endpoint comes up, I'm going to go work on my browser extension. So here's the part of my browser extension code that calls the scoring endpoint. I'm going to make a simple HTTP request, and I can paste in my URL here. And you can see the old model I was using. And when the scoring endpoint returns an emoji, this onload callback function will modify the headlines with the emojis. All right, our endpoint's ready now. So let's go update the browser plugin since we changed the endpoint name in the code. And it still works. So in just a few minutes, we set up a REST API endpoint for model scoring and built an application that changes the web content in real time. Not bad. But I promised to do better, so I've asked a friend of mine to build a better model for us. And it looks like she's been very busy and added 2 new versions to our model, and the serving system has automatically created endpoints for them already. Now I want to go and see the latest version, since it's probably the most sophisticated one. And it's using TorchMoji, a PyTorch implementation of DeepMoji, a by-LSTM-based text-to-emoji translation model. And she's also added contextual features for better accuracy. This sounds fantastic. But before I transition this model to production, I need to do some due diligence. So I'm going to compare the new versions to the old one. And in this view, we can see the information about each version that comes from both model registry and the source runs, like the parameters that we had logged. The yellow rows highlight the differences between the versions, and it looks like version 3 has a different model schema than versions 1 and 2, which makes sense since my friend said she added new features to improve the accuracy. So if I deploy this version now, my application will break because it's not sending in these new features. But we have version 2 here that has better accuracy than version 1 using TorchMoji as well, and has a matching model schema to version 1. So let's put this one into production. Now back in the serving tab, we see that the production URL points to version 2 now, which is great because it means I don't have to change my application code to use the new version. I am feeling a little nervous about that model schema difference I saw, so I'm going to try out the endpoint using this test box. Version 2 looks good, and version 3 errors as expected. Now it's time to see the new version in action. All right, so I'm very happy because 1, the model version update went seamlessly, and 2, the new model does seem better. And now my puppy page is even more heartwarming. So in under 10 minutes, we made the internet better twice. And even if you're not a subscriber of Puppy News, you can imagine applying the same techniques to other important domains like support tickets, user surveys, or customer feedback. To recap, today I showed you easy deployment of models, model versioning and collaboration, and finally seamless application updates using MLflow's end-to-end model management tools. Thank you for watching, and I hope this demo brought a smile to your face. Back to you, Matej. And here's a puppy.
Whoa, thanks, Suan. That was a great demo. So the last thing I want to end with is how to get started with MLflow. We made it very easy to get started with the platform. You can just install it through pip and it will just run on your laptop. You don't need to set up a server or create an account anywhere to use it. Just do our tutorial and you're up and running. If you want to try it in Databricks, it's available in the free Databricks Community Edition. And we also have an in-depth tutorial today at the summit at 11 a.m. for you to try it out. Finally, my talk was just scratching the surface of what's possible with MLflow. There are over 20 other talks at the summit from a wide range of organizations that are using it, and I invite you to check out these talks to see how they're productionizing machine learning with MLflow.
Thanks, Matej. I'm excited to have Rohan Kumar join us again at Spark and AI Summit this year. Rohan is the Corporate Vice President of Azure Data and the engineering leader responsible for the product development of all of Azure Data Services, including, of course, Azure Databricks. Rohan and the Microsoft team have been our strategic partners at Databricks, and together we jointly developed Azure Databricks Service that launched just over 2 years ago. Today, thousands of customers use Azure Databricks who run millions of virtual machine hours every day. Rohan is joined by Sarah Bird, who leads research and emerging technology strategy for Azure AI. She has a PhD in computer science from UC Berkeley, which is a popular university among the founders at Databricks. Please welcome Rohan and Sarah to talk about the latest research and development in responsible machine learning.
Thanks everyone for joining in, and thank you for having me. I look forward to the summit every year, and this year is no exception. I'm very excited to talk to you about analytics and AI and how you're reimagining the boundaries of what it can achieve. So many new AI capabilities have been talked about at the summit already. And today, I wanted to draw your attention to something that should be at the crux of all this innovation: responsible AI practices. Looking at how the world has changed around us over the last few months, and more so over the last few weeks, has greatly amplified the need for us to ensure fair practices and ethical behavior across all sections of society. To get a sense of the intensity of this topic, Capgemini published late last year that nearly 9 out of 10 organizations have encountered ethical issues resulting from the use of AI. These executives cited reasons including a lack of resources dedicated to ethical AI systems, the failure to consider ethics when constructing AI systems, and the pace at which AI is touching every part of our lives. The statistic is alarming. We as a community have a duty to address these issues head-on and empower organizations to use AI with a sense of responsibility. At Microsoft, we've also heard these concerns firsthand from our customers. As a result, we've invested in the advancement of AI driven by responsible principles that put people first. Our approach to responsible AI is anchored around the following focus areas: keeping ethical principles at the core of everything we build, enabling governance and operational transparency to drive right practices, leading efforts for public policy at the highest levels, and finally, empowering teams with cutting-edge tools to encourage responsible AI practices. Now, since the Spark and AI community comprises majorly of developers and data scientists, we'll focus on the tools. In collaboration with Microsoft Research, we are bringing the latest of research in responsible AI to Azure. Over the next few minutes, I will talk about how the new responsible machine learning capabilities in Azure and our open source toolkits empower data scientists and developers to understand machine learning models, protect people and their data, and control the end-to-end machine learning process. Let's look at each of these three pillars in detail. First, let's look at the understand pillar. It comprises driving an understanding of the model's fairness index and its interpretability. But what does that mean? One challenge with building AI systems today is the inability to assess and mitigate unfairness in the models. To address this challenge, we've recently open-sourced a toolkit called FairLearn. There are two components to FairLearn. First, focused on fairness assessment is a dashboard with both high-level and detailed views for assessing which groups are negatively impacted. Second, focused on mitigation is a set of algorithms for mitigating the observed fairness issues. These strategies are based on a variety of supported fairness definitions, such as demographic parity or equalized odds for classification tasks. The supported unfairness mitigation techniques can easily be incorporated into existing machine learning pipelines and assess model fairness during both model training and deployment. Together, these two components enable data scientists and business leaders to navigate any trade-offs between fairness and performance and to select the mitigation strategy that best fits their needs. Using FairLearn, developers and data scientists can leverage specialized algorithms to ensure fairer outcomes for everyone. Another important aspect of understanding a model is the ability to interpret or explain its results. This is where Interpret ML comes in. As the name suggests, it helps interpret models and their results. Interpret ML is another toolkit we've open sourced and can be used for both glass box and black box models. Glass box models are designed to be interpretable. They provide lossless explainability as they use interpretable algorithms like decision trees or explainable boosted machines. Interpret ML can help visualize the various features affecting the outcome of a model in an interactive dashboard and even allow for what-if analysis. On the other hand, black box models are based on more complex techniques like neural networks and can be a little tricky to interpret. You can still achieve approximate explainability with black box models using explainers like LIME or SHAP. Interpret ML uses these explainers to surface a dashboard with feature importance. Interpretability is needed to ensure that there is optimal transparency within models to assess and reason through the predictions it generates or the recommendations it creates. With FairLearn and Interpret ML, you can gain a very good understanding of your models. Let's now look at the Protect pillar. Protect refers to protecting data against any potential misuse used to train the models. To understand this better, let's envision a scenario where a data scientist wants to use some sensitive data to create a model. In a non-protected scenario, this would result in submitting a query to the private sensitive dataset, and provided the right credentials, they'd receive sensitive data as a response to their query. Well, this is problematic. Now the data scientist can look at the sensitive data and potentially deduce PII information about an individual. This is clearly not at all compliant or ethical. Now let's introduce a differential privacy toolkit within the OpenDP initiative that has been developed by Microsoft in collaboration with the researchers at Harvard's Institute for Quantitative Social Science. This toolkit ensures differential privacy by first managing exposure risk, by tracking the information budget used by individual queries and limiting further queries as appropriate. In our example, the query is first validated against the information privacy budget and processes only if it isn't overrun. Second, it injects statistical noise and data without significant accuracy loss to help prevent disclosure of private information. Again, in our example, because the query response may be sensitive, before it reaches the user, it is injected with noise to make it differentially private. In addition to differential privacy, you can also protect your data on Azure using hardware-backed confidential machine learning capabilities and homomorphic encryption and ensure your data isn't compromised at any stage of the machine learning lifecycle. The third pillar for responsible ML is control. It refers to tracing the lineage of models and supporting a standardized format of documenting it for cataloging and reusability needs. On the control side, there are some features and capabilities that allow you to manage your audit trail and data sheets for the models. Within Azure, all the actions undertaken throughout the lifecycle of a machine learning model can be tracked for auditing purposes. This audit trail enables us to trace the lineage of the training data, the operations performed on it, its drift, and most importantly, the model versions and the various deployment endpoints. Now, this is important. For compliance reasons, organizations can leverage this audit trail to trace how and why a model's predictions showed a certain behavior. Additionally, once you have a model, it is important to capture its properties and purpose alongside any other metadata that could be helpful from a reusability standpoint. In Azure, we enable this with custom tags you can define for the models and capture all its information so that it travels with the model. Audit trails and data sheets enable accountability for models and are an integral component of responsible ML. I've been talking about quite a few capabilities, so let's bring them to life with a demo. Let me invite Sarah Bird to demo these toolkits and show how you can use them. Sarah?
Thanks, Rohan. Hello, everyone. Today I'm going to be walking through a demo of some of our responsible AI tools on Azure. As we progress through the ML lifecycle, I'm going to be demonstrating 3 key capabilities: protecting sensitive information with differential privacy, assessing and improving model fairness with FairLearn, and analyzing and explaining model behavior with InterpretML. In this demo, I'm going to be building a model for loan applications to decide which to accept and which to reject. Let's dive in. Here I'm using Azure Databricks, but you could also use a Jupyter notebook or your favorite Python environment. Like any good model building scenario, the first thing I want to do is look at my data. Here I'm looking at aggregate information as well as individual features to help give me a feel for the data set and uncover any potential issues up front. It looks like this data set contains a lot of great data to help me build my model. It also contains highly sensitive information that must be kept private. Obviously, I can limit direct access to the data with the data store. However, what many people don't realize is that aggregate values can still be used to reveal private information about individuals. Let's go to an example to see what I mean. So here I'm going to demonstrate how we can use aggregate information to reconstruct the data set. So in this case, I'm going to assume that I know aggregates about individuals' income, as well as a little bit of additional information about 2 individuals in the data set. And with that, I can take an off-the-shelf SAT solver and use that to reconstruct a data set that's consistent with the information that we know. So if we run our SAT solver here, it's working to reconstruct that data set, and we see that it can actually find a result. And now we're going to compare that to the real data set and see how well our attacker did. So in this case, it looks like the attacker did pretty well. We're able to correctly reconstruct the incomes of individuals within $5,000 for more than 20% of the data set, which could be a significant privacy violation. So what do we do about attacks like these? How do we use data but still protect privacy? And this is where differential privacy can help. So differential privacy hides the contribution of individuals in the output computation by adding a small amount of statistical noise to the query. The noise is significant enough to protect the privacy of individuals, but often small enough to still allow us to use the data. Differential privacy also calculates the amount of information that is revealed in the query and subtracts that from an overall privacy loss budget. Let's look at how this works. So here I'm going to use our open source differential privacy platform, and now I'm going to add that statistical noise to the income information. And then I can retry my attack with my SAT solver, And what you'll see here is that we get a very different result. We aren't able to reconstruct a data set that's consistent with the differentially private incomes. And so we don't have any guesses at any private information. However, it's not enough to just protect privacy. We still want to be able to use the data. So let's look at how we're doing here. In this case, you can see that we're looking pretty good. We're pretty close to the original information. You can definitely see some noise added, particularly because this is a small data set. However, now I can take this and go and use it in my problem, knowing that I don't have to be concerned about privacy attacks. So one of the ways that we can use differential privacy in machine learning is to generate synthetic data sets. So here I'm going to use my open source toolkit, and I'm going to create a data set that matches the patterns and trends of my original data set, but doesn't reveal any private information. And that way I can take that and give it to my data scientist without having to worry about privacy. So I'm going to generate my data set here. And now that I have my private data set, I can go and build my model.
So here I'm going to build a scikit-learn model for my problem. And now that I've built the model, I want to actually analyze the performance and see, is it good enough for my problem? So of course, I can look at traditional metrics like accuracy. However, since this is a problem where a wrong decision could have a significant impact on an individual's life, it's important that I go a step farther and I also consider the fairness of my model. So in this case, I'm going to use FairLearn so that I can understand how well my model works for different groups of people and make sure that it's not using sensitive attributes to make decisions. So in this case, I'm going to use FairLearn, and FairLearn has an interactive dashboard to help me better understand the fairness assessment. So I'm going to click Get Started here, and my data set has two values, sex and race. So let's click into sex and understand how well my model's doing. But I also need to provide a performance metric, which metric's important for my problem. So in this case, it's accuracy. So I'm going to click through. And the first thing I have is a graph here that helps me understand the difference in model performance across these two groups. So I can see that my model's more accurate for women than men, and it's about 85% accurate overall. However, I'm really interested in the outcome of this model. What's the difference in who I'm offering loans to? So in this case, I can see that I'm offering loans to 19% of people overall. However, I have a significant difference in the number of loans I'm offering to women and men. I'm offering loans to about 7% of women that apply and about 25% of men that apply. Now, I don't necessarily know if this is a problem. It could be that these two groups have very different distributions. However, I do know that it's a sign that I want to dive in and investigate further. So for that, I can use Interpret ML and its black box explanations. So I'm going to generate explanations for my model here, and then I'm going to use its interactive dashboard to explore those and understand how it's making its decisions. So in this case, I'm going to set up two different cohorts. So let's set up one for women so we can understand what's going on there. So I'm going to add a filter for sex, and women are 0 in this data set, so we can add this filter, and I'm going to save. Then I'm going to add a second cohort here for men, and I'm going to select this. And in this case, I'm setting up for men and women since I want to look at this fairness problem, but you could use lots of different cohorts like train and test to compare as well. So in this case, what we can see is the model performance, just like we saw in FairLearn, but in a lot more detail. However, what I want to do here is jump over to the explanations to understand the feature importance and how the model's making decisions. And what I can see right away is that the model is using sex directly as a feature to make predictions for women, but not necessarily for men. And if I click on this, I can actually dive in and see that for women, for every single woman in the data set, the value of sex being 0 is directly contributing to the prediction that they are rejected, which is pretty concerning. And so what I want to do at this point is move on and explore mitigation techniques. So for that, I can go back to FairLearn and use some of the built-in mitigation algorithms that allow me to reduce disparity either during training or after.
So in this case, I'm going to use the grid search approach where I'm going to retrain many different models by reweighting the data to try to reduce the disparity. So I've run my model training here, and now I can go back to the FairLearn dashboard to look at the best models. So in this case now, I have a range of models that are along the curve of difference in predictions and accuracy. So here's my original model up here, and now I'm actually going to click through and look at this model, which is a little less accurate, about 82% accurate. But if I jump down to the disparity in predictions, I can see that I have a much different outcome. Now I'm offering loans to 15% of men and 14% of women that apply. So this might be a much more promising model for my problem. And so what I'm going to do now is actually save all of my work so that I can share it with collaborators or show it to other stakeholders as we make a decision about whether or not we want to move forward with this model. So I'm going to register all of my models here. I can upload my dashboards and my explanations, everything to Azure Machine Learning. Then if I move over to my Azure Machine Learning Studio here, then I can click on a particular run. And so here's my different runs, and I can click into one. And now I can actually have my dashboard stored directly with my model, as well as the fairness. And so now I can show this to other stakeholders or compare to previous models as I decide whether or not I want to take this into production. Back to you, Rohan.
Thanks, Sarah. It was so nice to see all of these machine learning tools come to life with the loan scenario. Just to add more color, this demo is very similar to what EY is doing with these toolkits. They're using FairLearn extensively to mitigate unfairness in models. They've been able to reduce their disparity by more than 90%, which is amazing. And many more customers are using these toolkits to build responsible machine learning practices. I want to take this opportunity to invite the community to get involved. Contribute to the open source projects powering responsible machine learning capabilities. Create scalable impact with the objective of having ethical AI practices and solutions. All these tools are hosted on GitHub and already have hundreds of downloads within the last few weeks. If you want to try them in action, please use the Azure links to try them within Azure Machine Learning or Azure Databricks. With that, I want to thank... Oh wait, did I forget something? Well, I must let you in on a little secret. This one about my presentation environment. I'm sure most of you think I'm in front of a green screen here, and there are some graphics people doing their magic in the background. We thought of experimenting with AI a little bit and putting it into the use just for the summit. First, let me show you where I am. This is not a formal studio. It is a normal living space where I just came in to record this talk. Now let me show you how it was converted to a presentation stage for me. We use Kinect and the Azure Kinect Dev Kit to bring AI and AR together to simulate the stage. Here's an architecture of the solution that produced the video for this talk. Amazing, isn't it? We use normal camera images and depth sensing Kinect camera images to replace my actual background with the stage and design of our choice. I thought about a beach in Hawaii, but opted for a bit more presentation-friendly option. This is just an example of how together we can stretch the boundaries of AI. The solution has been published in a GitHub repo, linked here for you to use for your next meeting or video call. Again, thank you for the opportunity to share. I hope you have a great summit. Please stay safe.
Thanks, Rohan and Sarah. Next up, we're going to hear from a company that is leading the way in the financial services industry. They are doing this by embracing open, cloud-based platforms like Azure Databricks and MLflow that enable the democratization of data and machine learning across the business. I'm pleased to introduce Anurag Sehgal, Managing Director of Data Analytics, AI, and Digital Innovation at Credit Suisse.
Hello, everyone. Happy to be here at the Spark in AI Summit. My name is Anurag Sehgal, and I run data analytics and machine learning and AI at Credit Suisse within the Global Markets division. I'm here to talk about how data and digital are transforming all aspects of how we do business as a bank. We've gone from a traditional approach, a human-centric customer approach, to a digitally connected client journey where digital solutions augment human expertise. There's an exponential demand for insights and data-driven answers from our clients. Our business models have gone from a predominantly bespoke and expert judgment-driven approach to digital platforms that allow us to drive into new markets or new routes to customers. The value proposition for our sales, trading, and research teams continues to evolve as well. Our trading teams are looking for real-time intelligence on how to price, how to manage inventory, how to drive RFQs. Our sales teams are looking for insights in what clients are interested in, what products they're interested in, what stocks they're interested in. And our research teams are looking to differentiate our content and our advice to clients with data and distinct and differentiated analytics. Data analytics is at the core of everything we're doing. We've gone from leveraging traditional financial market data, price data, to leveraging alternative forms, nascent forms of data in driving unique insights, intelligence, and recommendations for our clients. Data and AI machine learning are a core driver of how we evaluate where we go next. In order to achieve this transformation, our goal is to foster the generation of ideas, new ideas, in enhancing and growing our business with data analytics, allowing for experimentation, rapid prototyping, and having a VC mindset in leveraging and driving mature, commercially viable ideas into products and business ventures. In being able to do that, we're setting up ideation events, forums where ideas come to life, be it Shark Tanks, hackathons, or design thinking workshops, in partnering with digital champions and digital advocates across all our businesses in rethinking, reimagining our business and business process, and how we deliver most value to our clients. We're looking at how we go from ideas to pilots, prototypes, to minimum viable products, and having a clear digital product strategy and how we go to market. This wouldn't be possible if we weren't prioritizing our idea funnel with a very clear mindset of looking at ideas that are most viable and most critical for us to take our business forward. None of this would be possible without having a core foundational platform that allows us to drive rapid prototyping, rapid ideation, experimentation, and take the ideas that are most commercially viable to that scale out mode. So what does our core foundational platform look like? Well, our goal is to look at large amounts of both internal and external data, in ingesting large amounts of data onto our platform, in looking at not only structured data but unstructured data, and looking at all kinds of real-time streaming data. And so the forms and types of data that we're ingesting into our platform continues to evolve. We've set up a metadata-driven data ingestion framework that allows us to go from defined metadata to ingesting data, to enriching those metadata sets, to being able to look at quality monitoring of our data. And so data quality plays a key role in the consumption of this data, in consumers gaining confidence on the platform and on the data that they're using. We're using anomaly detection to be able to look at data quality in very different ways. Analytics is a core part of the foundation. Machine learning and AI is a core part of how we achieve success. With the growth and in the use of machine learning, our goal is to democratize the use of machine learning and AI. So the way we're achieving that is through machine learning sandboxes, in sandbox environments that allow our data scientists to be able to develop, deploy, and test models rapidly. In being able to look at derived trading signals and factors that can be derived from the underlying raw and enriched data. In recommendation engines and NLP engines that allow us to very quickly consume unstructured forms of data and create insight from it. Obviously, part of this ecosystem includes the ability to have that life cycle management in models and in algorithms that we develop on the platform. The insights from these algorithms and the data insights that we're driving is delivered to our clients, to all our internal personas through various different channels. One of the key channels is through the visualization and reporting and business intelligence layer, but we deliver insight to our end users where they need it at the moment and point they need it at. So for our clients, it's through our client portals, through APIs, For our sales and trading teams, it is through our sales trading desktops at the point where they're making decisions on RFQs, or on IOIs, on any axis. And APIs play a key role in the sort of flexibility that the platform provides us. As we embarked on the platform, we needed to set some core design principles, some core architecture principles in what would drive the success for us in the short, mid, and long term. Being on the public cloud was of utmost importance to us. Having platform as a service capabilities that provide, multi-cloud enablement, that provide for cloud agnostic capabilities was critical to us. The ability to scale up and scale down is something that we did not have on-premise, and the ability to automatically provision infrastructure on the cloud was a key feature we needed. Next-gen technologies for machine learning AI and a consistent user experience for our data scientists, our data engineers, our business analysts was a key part of the principles we set ourselves up with. Databricks and MLflow are key tenets of how we achieve these capabilities on the cloud. Data security, being comfortable with putting confidential data on the cloud was a journey for us. Providing for efficiency in how we deliver and what we deliver, with CI/CD, with continuous improvement, with integration, with sprint based deliveries, with agile capabilities, was a big part of our core principles. As I mentioned, machine learning and data mining was a key focus for us in this journey. And so the types of things we're doing around machine learning and AI include, within natural language processing, include tonality and sentiment analysis, topic detection, event detection, and text summarization. Graph analytics and pattern mining is extremely important to us, from evaluating strongly connected entities to looking at sequence of events to look at community detection. Predictive analytics was important in areas around anomaly detection of market data, to recommendation engines for sales, to pricing and fundamental analysis for our trading teams and our quant teams. To achieve this, we very early set out to create a sandbox environment for data scientists to be able to very quickly enable a sandbox with all kinds of open source libraries, open source machine learning libraries, that allowed them to develop and deploy models fairly quickly. So we created an NLP image and a quant predictive image that allowed for us to fairly quickly take all kinds of new machine learning libraries and put them into the hands of our data scientists on this cloud environment. Obviously, with these images and these sandbox environments are key for data scientists, but the development environment for models, the deployment, and lifecycle management of models was as critical a feature in this process. And so, for a data scientist to develop models, their IDE environment was the Databricks notebook. For a data scientist to deploy and test these models, we allow for compute capabilities both on scale out and scale up modes. So scale out using Spark and scale up using dynamic GPU cluster management. To manage the model lifecycle, we use MLflow, and we'll talk a little bit more about model lifecycle management and our approach to model lifecycle management. But also to be able to visualize the results and the outcomes from these models, our data scientists use all kinds of capabilities, from Databricks to Tableau to other features and other visualization libraries. So as I mentioned, machine learning and AI model lifecycle management is critical to us, and our approach to machine learning model lifecycle management is very similar to all other models we run for in risk or in our trading systems. And so model registry and versioning of all our models, but essentially includes all aspects of data, all aspects of model code, logging and versioning of parameters and hyperparameters, versioning of taxonomy used in a model, corpuses used in a model, validation and monitoring metrics used by a model. All of that is controlled, is registered, is version controlled through this life cycle. Here are 3 case studies and examples of how the platform is starting to create value for our business. We're seeing recommendation engines deliver personalized recommendations to our sales teams around products our clients are interested in based on a variety of signals and data sets. We're using alternative data insights in unique ways to measure company performance, to look at sector performance, to look at macroeconomic views, as an example, to look at economic recovery from COVID-19, look at trends in the ESG space, and enhance our products with differentiated alternative data insights. We're starting to look at digital platforms and the use of digital platforms that is allowing us to expand product coverage and distribution capabilities to offer unique new products and services and reduce operational friction and create efficiency in our business process. So as we look to the future, our goal is to continue to enable both offense and defense value cases in how we empower our business with state-of-the-art digital capabilities and data-driven intelligence to both enhance our core products but also offer new products and look at how we can continue to drive efficiency and growth, leveraging data and digital. Platform-based solutions, as we look to embark on network effects and gain the value of platform, we want these network effects to continue to play out. We want to leverage digital platforms to create new markets and new routes to customers and deploy more and more product via digital platforms. And lastly, we want to continue to turbocharge data analytics, embedding machine learning and AI in all aspects of how we do business, in creating value for our clients as well as for our internal sales, trading, and research teams. I'd like to thank you all for joining me at the Spark in AI Summit today. I hope you found my presentation useful and informative. Thank you.
Thanks, Anurag, and many thanks again to all of our speakers this morning. Some quick reminders for you all. First, please do attend the breakouts. They're awesome. Also take some time to visit the Dev Hub and the Expo in your dashboard. Also, this is a great opportunity to network, connect with your peers, engage on social media, take a selfie and share it, use hashtag #DataTeams and hashtag #SparkAISummit. And finally, we have a chance together to raise $200,000 for CPE and NAACP in support of racial and social justice. Just click Donate Now in the dashboard and donate any amount. Thanks for attending Spark in AI Summit.